Welcome to Sravz technical series. In today's session, we'll continue with the Golang crash course. In the previous session, we discussed the development environment setup. So Golang crash course, this is the link. And we discussed the development environment setup, where we discussed the Docker Compose, VS Code inside a version, and development environment in the container. So today we'll go through the project structure, and then we'll discuss basic REST API service using Gorilla Mux. So this is the code base. So if you look here, it's running in a dev container in training Go. It's a container, a Docker container, and this is the code base. And the code is uploaded to the training Go directory. This is a mono repo. So we have C++ code base, then you go some Python code base, and this is the Go code base. So it's a mono repo, so everything is in a single repo, and then everything is driven off of this Docker Compose file. And the Docker Compose file has the containers, etc. So if we go back to the VS Code, so code base here, training.go, we opened in the container. So we'll go through the project structure. In the Go language, we use a concept called Go modules. So we define a Go module in go.mod file. And the go.mod file starts with the module name and the full path to the GitHub where the code base is. So this could be GitHub or Bitbucket, any other repo. And then the username where the repo is. And in our case, since it's a mono repo, we have training and training-go. So if we switch back to our GitHub page, so we have training, and then training as the training.go directory. So this is what we put in the module name. Then we have the minimum version of Golang. In our case, we put 1.16, so it could be higher. And then the requirements. These requirements can be auto-generated too. So if I delete this and then run go.mod tidy command, go.mod tidy is run, it will get the modules that the main module is dependent on, and it will put the requirements here. And go.sum file will get the sums of the repos we are dependent on. This is auto-generated, and it's similar to package.json -log file in Node.js. So this need not be this is auto-generated, so we don't have to worry about it. So that's how we set up the Go environment. And then there's another command called go.mod vendor. Go.mod vendor will create a vendor directory, and then in the vendor directory, it will get all our dependencies. In our case, we are dependent on the Gorilla Mux. So vendor directory will have github.com Gorilla Mux, and it will pull the code base from Gorilla Mux to our local directory. So this way, Go will have all the dependencies it needs to compile the program. So once we have the dependencies in vendor, you could check in this to GitHub because it's just another GitHub repo, or you can not check in the vendor directory. In that case, you have to do go.mod vendor each time you have to you clone the main repo. So it's an option, but I check in the vendor directory. So once you go.mod vendor and the dependencies are here, we can do go build. So go build will build a program, and then it will create the executable. In our case, our executable's name is training-go. So it builds and it will create training-go. If I do date ls minus -lalt, so it's just created the 2023. So it has just created the executable. So that's how That is how we create the executable. Now, there's another directory called packages, which will have all our packages. So the main.go file is our main package, where we have the main function. So similar to C, C++, Java, we have the main function, and then it's the main package. So if we are creating an executable Go program, it has to have a main function. So this could be any name doesn't matter, but there should be a main function and main package. So we created these main package, and then our main package depends on other packages within our repo. For example, background, config, crypto, DB, middleware. These are other packages our main package is dependent on. So if you try to compare this with the Java, this could be another jar file, or another directory path where your sub modules are. So in our case, we have these other packages our main package is dependent on. So Go convention is to create a package subdirectory, then create a directory with the package name, and then create a file with the same name. So if you look here, each package directory has a file with the file name, and then the main will import the dependencies using this path, github.com training.go. This is our module name. So this is our module name, which is defined in mod.go. This is a module name. And then any package underneath that directory, package background.go, can be added this way. But you don't have to add it manually. If you are running in this container in VS Code has a good Golang support. So for example, if I delete this and then save it, and it should give us quickly that something is missing. So main.go formatter. So the Go formatter will help us add the required dependencies. So now, the formatter automatically added the background. So if you're running in VS Code and have Microsoft Go VS Code package, it will automatically help you add the dependencies. So you don't have to manually type it. So with that, we discussed the package directory, the vendor directory, and then main.go. And in Golang, there is a environment variable called go root. So we define an environment variable called go root. And so it doesn't show here. Go path is -go. So go root is the location where all our Go modules are present, the system provided modules. So in this case, these are the system provided modules. So the Go root will have these modules. So that's how Go system will find out the system modules. So with that, we conclude the discussion of uh, the project structure. We'll go through the individual file names, individual files. So main.go is the main function where our program starts. In the main function, we write the application, the start point. So today in this session, I'll go through the main.go, and in the subsequent session, I'll go through the packages. So the packages we'll discuss, in the packages we have used important Go concepts. So we'll discuss those. So after main.go, so this is the main function where the execution starts, and we defined a variable of type time.duration. So the duration could be any type. So then we used a Go module called flag, which gives us command line parameters. So we take these parameters to the function takes these parameters. So if I run the execute, So these are the, it shows the usage, and the usage is driven off of this flag module. Now the flag module takes various variables. For example, duration variable takes a placeholder of time of type time.duration, and we put an ampersand here because it expects a pointer to the variable. So when you pass something by ampersand, it means the reference, the address of weight. So this way, this function will have access to weight variable, and it will update weight in place. So though weight is defined in this function, when flag.duration is executed, the value is stored in weight. So the flag.duration function will read our command line parameter and put the value in this main function variable. And these are the parameters to duration.var. Similarly, string.variable. Then once we provide our variables, we parse it. So this is how flag is used. And then we have defined some variables here. Crypto.cryptos is of type map, which is similar to dictionary in Python, of type key type string, and value type crypto.crypto. So the maps a crypto, for example, Ethereum, Bitcoin, to a crypto.crypto structure. And then we do a make to initialize the memory in heap. This is not defined on the stack. With make, we allocate memory in Go, and then make returns the address of that location, which is assigned to crypto.cryptos variable. So if you go to crypto.cryptos, so it's a map of string and cryptos. It's a package level variable. Similarly, symbols is a package level variable of type strings. It's an array of, it's a slice of strings. It's a slice of string. In Go, we have arrays and string, array and slices. When we do not specify the uh, the size, it becomes a slice. A slice is similar to C++ vector, which is dynamic in memory allocation. So when you exhaust the allocated memory, it will resize automatically. So it's similar to C++ vector. The moment you define a size here, for example 6, it becomes an array, C array of fixed size. So once you go, once you assign more than 6 elements, then it throws an out of bounds error. So we created a slice here, and then to that slice we are assigning symbols, which are comma separated symbols here, and then those symbols will sit in the slice. And then we used Gorilla Mux router to create a HTTP router. So Gorilla Mux is another package which is here, Gorilla Mux. Today we won't go through Gorilla Mux library. Also, they have stopped development of Gorilla Mux. Right now it's public archive only, but it's a simple, it's a lightweight wrapper around Go HTTP module. So it's still, though it's not being actively developed, it's still feature rich. So for our use case, we can still use it. So we created a mux router. To the router, we add some paths. To the path, for example, crypto, for example, currency dot symbol, we assign this function get crypto of method type get. So whenever we pass in currency symbol as the parameter, the path to the HTTP, this function is called. Similarly, for /db, this function is called. And then we add a bunch of middlewares. So we'll go through all of these in the next session. And then there's a concept in Go called Go routines. So this is where the power of Go comes in. A go routine is a function which is run on a separate thread. So by simply putting go in front of a function, it's executed in a separate thread. It's much easier than creating a thread and assigning a function to it like we do in Python and other languages. So go is a Golang keyword. When we add that in front of a function, it runs in a separate thread. So here we defined an anonymous function with no function name. Like for example, here if you see, we created a main function with a name, but here it's an anonymous function. There's no name to it. Then we put go keyword in front of the function, and then we immediately execute the function with these two braces. So it's an iffy immediately executable function. So when the main thread is here, go will schedule this on a separate function, and that's how we get this for loop runs in a different thread, and then the main thread will proceed with the rest of the code. Then the main thread will create an instance of HTTP server, provides the address where the HTTP server should run, and then provides the Gorilla Mux router we created up here. So this router is provided to the HTTP server. And then we create another Go function, Go routine, which is immediately executable. And then we start the HTTP server, and we'll start the listener on the HTTP server. So the HTTP server will listen at 80. And the rest of the code base from here, line 64, will cover in a separate video. And when we cover this line of code, we'll go through the packages and the other concepts in Golang. So for today, to quickly wrap up, what we have discussed is the Go code base, the project structure, the main function, the imports, and Go routines. The Go keyword, when we put a Go keyword in front of a function, it is executed in a separate thread, and this is where the power of Go comes in. Now to run this code base, there are two ways. Either you could create the executable like I did here, go build. Go build will create an executable training-go, and then you can simply run that like I already did here. Training-go takes the default parameters. So for example, these have default parameters of this one and this one. So that's why it didn't ask for any input and it's able to run. So that's one way. Or the second way is to run air. Air is another tool which I mentioned in the README file. Air will do live reloading of the code base. So install air allows live reload of Golang code. So you can do that with go install. When you use go install to install air, it will install it in the go path. So then if I cancel out of this with air, go bin air, so it's in the go root, so it installs there, and then because of air, and then you create another file called go air.toml. In our case, we don't have to control P. So once the air is installed, you just run air. Air will pick up the executable it has to run, and then it will run the go program for us in the background. So whenever you make any changes to the go file, for example, here I just add a new line, it will automatically detect which file has changed, and then it will live reload that, compile the code base, and then run the updated code base. So this way, so it has detected this file was changed, it compiles the whole code base and then restarts the server. So this way you can do quick development because of live reloading. So with that, I'll conclude today's session. In the next session, we'll go through the package directory, and then we'll also go through the Go test cases. For example, here I've written some Go test cases, and in VS Code we can see the Go tests, and VS Code provides a package to run the Go tests, so we can use this package to run the Go tests. So it's see, it runs the test, so it's a quick way of running the unit tests on the Go program. So if you have further questions, please ping me in YouTube channel or on the Sravz documentation site here, and I'll answer them accordingly. Thank you for watching.